Now we're being asked to use the remainder theorem to determine if these two values of c are zeros of the polynomial. In other words, when we do long division, will we get a remainder of 0? So here we go. Our polynomial is 2, negative 5, or the coefficients of it are 2, negative 5, 54, and negative 26. And I'm going to check whether 1 plus 5i is a 0. So here we go. Bring down our 2. 1 plus 5i times 2 is 2 plus 10i. Adding down, the real parts give us negative 3 plus the 10i, the imaginary part. Now we've got to go 1 plus 5i times 3 plus negative 3 plus 10i. I'm going to need some scratch paper to do that, and I'm going to do that right down here. 1 plus 5i times negative 3 plus 10i. Here we go. First term of FOIL is negative 3. Outer term would be plus 10i. Inner would be minus 15i. And the last term would be plus 50i squared. Now that 50i squared is going to be a negative 50, and that negative 3 make negative 53, and we've got two middle terms that make negative 5i. So adding to what's up above, we're going to have 1 minus 5i. Now we do our next multiplication of 1 plus 5i times 1 minus 5i, but here we're multiplying conjugates, and so the middle terms of FOIL will cancel, and so we just have 1 times 1 is 1, and we're going to have minus 25i squared, which is 1 plus 25, making 26, and we have 0 as a remainder. Now, since the remainder is 0 here, the answer is yes. 1 plus 5i is a 0 of this polynomial. Now, let's do the same thing over again, but this time testing for 1 minus 5i. We still have the same polynomial there, and I'm going to slide this up and bring down the first term, which is 2. 1 minus 5i times 2 is 2 minus 10i. Adding down, we're going to have negative 3 minus 10i. Now we've got that same ugly FOIL problem to do. 1 minus 5i times negative 3 minus 10i. First term of FOIL is negative 3. Outer is negative 10i. Inner is plus 15i. And the last will be plus 50i squared, which makes a negative 50, along with that negative 3 there out front, gives us negative 53, and the two middle I terms give us a plus 5i. Adding down in that third column, we get 1 plus 5i. Multiplying conjugates again gives us 26, and adding down we have a remainder of 0, which tells us yes, 1 minus 5i is also a 0 of the polynomial.